Let's see how you're doing on the first two here, and then we'll take a look at, they'll give you a second to work on the third one. For number one, remember we start out with the ratio of lengths. And our ratio of lengths for number one is what? 20 over 12 or 12 over 20, either way. Yep, this new computer is not going to make it very long. Oh, this morning I've wanted to throw it a few times. Both of those, to make this easier when we go to work with these, I'm going to reduce that. Both of those can be divided by what? 4. So 20 divided by 4 gives us 5, and 12 divided by 4, 3. Now we need to find a relationship between the areas. How do I find the ratio of areas? Well, I've got to deal with the ratio of lengths, so I got to get the ratio first before the 720 does us any good. I've got to square it. Perfect. 5 squared, 25, and 3 squared, 9. So that's my ratio of areas, is 25 over 9. Now where does the 720 go? On top. And to find my missing number, I cross multiply as soon as my display comes back up for you. 9 times 720 divided by 25. Okay, are we coming back here or not? So 259.2 is correct. And that, of course, is going to be in square inches. Number 2 up here. Ratio of lengths is going to be what? 8 over 15. That one can't be reduced. So let's turn it into a ratio of areas. What am I going to do to it? Square it. So that's going to become perfect. 64 over 225. And we're going to let that equal 96 is going to go on top over blank. And we will cross multiply and divide. 225 times 96 divided by 64. Yep, 337.5. And that's going to be square feet. Okay, so number 3 down here was off screen, so I'm going to give you guys a minute to work on that quick. Okay, so for number 3, I know you guys didn't get a lot of time to look at it before it disappeared on you. But we're going to start out the same way. We've got to have that ratio of lengths. What's that going to end up being? 6 over 10 or 10 over 6. And both of those numbers can be reduced by, yes, they can be reduced by 2. And we don't have to reduce them, it just makes life, what's that? Can't hear me again? Okay. How about, is that better? Okay. Thank you for letting me know. Apparently it's going to be our day for technical difficulties. So yes, both of those have that ratio. It could be either 6 to 10 or 10 to 6. And both of them can be reduced by 2 just to make this next step easier. So that reduces to 3 over 5. So now for volumes, what do we do? Nope, I am. So yes, we do have to cube it. 3 cubed is? Is 27, and 5 cubed is 125. So now on the other side, we've got the volume of 1080. Which one does that go with? Top or bottom? Yeah, that one with the 10, so it has to go on bottom. So now we're going to cross multiply and divide. 27 times 1080 . Oh, that didn't work. Yep. $233.28. And that is in inches cubed. Okay, now where we left off on Thursday, we were talking about graphing. And I'm going to pull up this worksheet again. Yeah, I got to go through a few menus to get to stuff. We graphed these first couple here. Number 1 here, y equals 3x minus 2. Looks something like this. Second one, y equals 6 minus x. Looks something like that. Number 3, y equals so did we just lose Ashlyn? Can you guys see yet? We just lost you for a second. Okay, can everybody see the content, the computer screen? Okay. Y equals x squared plus 2x plus 1. Ended up being something like this. And then here, number 4, y equals the square root of x plus 6. Looks like that. Number 5, Y equals 3 plus 3x. Looks like that. Number 6, y equals 2 to the power of x. Looked something like that. Remember we talked about asymptotes? And number 5 just disappeared, and so did number 6. Okay. Let's try that again. Oh, Jesus. They're going to get this computer back in a box pretty soon. Okay. Sorry, I don't know what happened. It just fell apart in the middle of class. Number 7. Y equals x to the third minus 1. Looks something like that. Number 8. Y equals 8 over x. Looks something like that. Remember, those had asymptotes too, where you had the line here for the axes that could not be crossed. And number 10, 4x squared minus 8. Looks something like that. Technically, it is rounded at the bottom there, but just barely. And number 10, y equals 3/4 x minus 4. Looks something like that. So the big question we want to start out exploring today is, how do we know which ones are going to form lines like this and which ones are going to form curves that are not lines, like number 9? So as we look through this, obviously both 7 and 8 here did not form lines. They formed other curves. 5 formed a line. 6 made another curve. 3 and 4 both were other curves. And 1 and 2 were lines. So if we take a look at let's just make a list of equations that made lines and ones that were not lines. We had 3x minus 2 and 6 minus x were both lines. Come on. So those were lines. Y equals x squared plus 2x plus 1 were not lines, was not a line. Y equals the square root of x minus 6, or x plus 6, I should say, was not a line. We had y equals 3 plus 3x was a line. Y equals 2 to the power of x was not a line. Y equals x to the third minus 1 was not a line. Y equals 8 over x was not a line. And the final one that was not a line was y equals 4x squared minus 8. And then we had y equals 3/4 x minus 4. That was a line. So as we look these over, we want to look at what is the difference between those equations. More specifically, what makes these not lines? What do these have that these other ones over here don't have that makes them not a line? The powers. Now the powers, I need to be more specific a little bit, because if I had y equals 2x minus 3 squared, that would still be a line. What's different about this power? What's that? It's a power. There you go. We can't have a power on the variable. Now I'm going to put in parentheses here, other than 1. Can't be a power other than 1, because remember, a variable has a power of 1. It can't be squared. So that gives this going to include, x squared, x to the third. That also includes the square root of x. Because remember, we said roots and powers are all part of exponents. So that includes this one, that one, and that one are all described there. There's still 2 more, though, that wouldn't be covered by that. What would we see about those? That x is the exponent, x is the power. The variable is the power. So we cannot have the variable be the power. That would cover this one. So there's still this one. What's going on there? Dividing by the variable. Very good. So we can't divide by the variable. These are what I often refer to as the 3 don'ts of linear equations. Because these are the 3 things that linear equations don't have. If they have one of these 3 things, it will not be a line. So let's try some here. Will that be a line or no? But there's a power in it. Not on the variables. Yes, that is a line. How about that one? That is a line. There's division in it, but we're not dividing by the variable. How about that one? Not a line because it's x to the third. How about this one? But there's division with the variable, but we're not dividing by the variable. Very good. That is still a line. How about that one? That is not a line. You're right, because the variable is in the power. How about that one? Why not? X squared. Very good. How about this one? Yes, because that just combines to make y equals 25 minus x, right? 5 squared is 25, negative 3x and positive 2x is just negative x. How about that one? You're exactly right. It is not a line because we're dividing by x. Even though it's not 7 over x, we're still dividing by x. So now that we can look at an equation and tell relatively quickly if it's going to be a line or not, let's focus in on lines and see if there's a shortcut for graphing them. So we're going to start out with the simplest linear equation that we can imagine. Y equals x. And so far what we've done is we've just plotted points. We've picked values for x, figured out what y has to be, and then put that point on the graph. So let's say x is negative 3. If y equals x, what's y have to be? Negative 3, right? So that point, negative 3, negative 3. Oops, wrong spot. That would be right here, right? Negative 3, negative 3. If x is 0, what's y have to be? 0, so right there. If x is 2, what's y have to be? 2. So you can see we get that line. If I'd drawn it well, let me try that again. It goes corner to corner from a graph. It goes through the center, through the origin, and it goes corner to corner across a graph. Y equals x. Now, remember when we talked about solving equations, we talked about building equations and things that can be done to build onto an equation. Here, we only have to build onto one side of the equation. We don't have to build onto the x. We're going to leave it as y equals. But some things we could do to build our equations, we can add, subtract, we can multiply, we can divide. We can even do powers and ruts, but if we did that, this wouldn't be a line anymore, so we're not going to do those here. Well, let's try to add. Let's say if we add 2, so y equals x plus 2. What's that going to look like? Well, now if x is -3, what's y going to be? -1. Very good. So that's going to be like right here. -3, -1. If x is -1, what's y going to be? +1. So that's going to be like right there. If x is 1, what's y going to be? 3. So 1, 3 is going to be right there. Looks like that. Notice it is parallel to that original equation. It just did what? Yeah, it just simply moved up 2 spots. But I'd drawn it right, it would actually have gone right through there. So what do you think would happen if I did y equals x minus 3? Down 3 spots? Okay. Well, if x is -2, what's y going to be there? What's -2 minus 3? -5. So -2, -5 is going to be right there. That's about right. If x is 0, y would be -3. Yep, right there. If x were 2, y would be -1. So 2, -1. And it appears that you are exactly correct. It's parallel. It's just moved down 3 spots from where it was, from the origin. Now, we've added and we've subtracted. Let's try multiplying. Y equals 2 times x. If x is -2, what's y going to be? What's 2 times -2? -4. So -2, -4 is going to be right here. If x is 0, what's y going to be? 0. 2 times 0 is 0. So back to the origin. If x is 1, y has to be 2. 2 times 1 is 2. So 1, 2 is a point right there. So yes, notice it's back going through the origin to the center. It just makes it steeper. So if multiplying makes it steeper, how do you think we would make it shallower? Dividing, like y equals x divided by 3. Now, because of the algebraic nature of what we're doing here, rather than writing it as x divided by 3, remember when we divided with fractions, what did we do instead of dividing? We multiplied by reciprocal. And when we're graphing, rather than dividing by 3, it's easier to do 1/3 times x instead of x divided by 3. That's still dividing by 3, but it's going to do the same thing. So if x is -3, what's y have to be? -1, right? So that's going to be right there. If x is 0, what's y have to be? 0. So that's through the center still. If x is 3, what's y have to be? 1. So sure enough, we do get a line that is a shallower angle across the graph. So far, though, you'll notice all of these lines, as we go left to right, go up. How would we make one go down, you think? Multiply by negative. Now, if x is -2, y is going to be a +2. If x is -1, or sorry, if x were -2, y would be a +4. If x is -1, y is going to be a +2. If x is +1, y is going to be a -2. So we would get that downward angling line like that. So realistically, there's only 2 things we can do to an equation when we graph a line. You okay? Okay, there's a number that multiplies the x, and there's a number that's added or subtracted to the x. So let's say we have an equation here, y equals 2x minus 3. Does this line go through the origin? To the center? No, the subtracting 3 tells us it goes down 3, right? So we're going to start out down here. And the 2 tells us that it's going to be steeper than, rather than having this, 45-degree angle across the graph, it's going to be steeper than that. So something like that. Well, looking at this here, this number that's added or subtracted on the end, which it was a -3 over here, is what we call the Y-intercept. That is where the line starts on the graph. Now, if you recall, this vertical axis here was called the y-axis, or the independent axis. So that number that's added or subtracted is where the line intercepts or crosses the y-axis. In other words, it's where the line starts. Normally it would start at the center of the graph here, but that number moves it up or down from there. This number here that multiplies the variable, that was the 2 in this example, is called the slope. And the slope we're going to take some time to discuss and develop right now. The slope is just a ratio similar to the ratio that we call the slope for a house roof or a building roof, and it is defined to be rise over run. So here we had 2 as our slope. Well, that's not really the way the slope is written. And we wrote it as 2 because that's how we're used to seeing that number. But a slope is really always a fraction. So technically that's a 2 over 1. What that means is from the starting point. So here that was at the -3 down here. From that starting point, we rise 2. So we go up 1, 2, and we run 1. So we go over 1. That's our second point on the graph. We could keep doing that to get more points if we wanted to. Rise 1, 2, and over 1. Like that. So if I have an equation like this, y equals 2/3 x plus 1. We always start out by looking at the y-intercept. Where does this graph start out at? +1. So from the center, we go up 1, right there. That is the first point on this line. The second point then is found from that starting point and the slope, which in this equation is 2/3. So from this point, we're going to go up how far? 2. Up 1, 2, and over 3. 1, 2, 3. There is a second point on the line. Now I could keep doing that if I want to find more points. I can go up 1, 2, over 1, 2, 3. There's more points on the line. Some people are comfortable drawing the line through just 2 points. Others want a third or fourth point there to keep going with it. So y equals a -3/4 x plus 2. Where are we going to start? +2. So we go from the center, we go up 2. That's our first point. Now this slope is -3/4. The negative or positive goes with the rise. The run is always going left to right. It's the rise that is either up or down. So since that's negative, from our starting point, we're going to go down 3 and over 1, 2, 3, 4. There's our line. I hear you. Where's this one going to start? -2. Very good. So we go down 2, and that's where it starts out. From there, what do we do? Yep, we got to take that 3x and make it this 3 over 1. So from this point, we go up 1, 2, 3, and over 1 right there. Close down that worksheet, make it easier on myself. How about if I have y equals 3 minus 1/2 x? Where does this one start? Careful. The -1/2 is multiplying x, isn't it? Notice up here, x was always the first thing in each equation. Down here's at the end. Doesn't matter. It's the number. Yes, it's the number that's multiplying the x is the slope. It's the other number that is our y-intercept. So here we have that +3. That's where we're going to start out at. From there, then, our slope is a -1/2. So where do we go from that point? Down 1 and then to the right 2. Remember, our run is always left to right. The positive or negative goes with the rise, not the run. Remember, if a -1 over 2 is negative, right? But if I had a -1 over a -2, that means I went down and backwards. That means it makes it positive. So I can't do that. That doesn't equal that. Technically, I could do a +1 over a -2. But that means that from this point, I would go up 1 and then back 2 spots. That works. But the negative has to go with one or the other, not both. In order to have a negative slope, you have to have one positive and one negative. So we tend to stick with making the rise the negative and keeping the run always positive. So I'm going to have you guys try some in your notes here. Try those four in your notes quick. See what you come up with. Okay, so for the first one there in blue, where do we start? Positive 1. Right there. From there, where do we go? Down 3, 1, 2, 3, and over 2 to the right. Very good. There's our line. Pretend it's straight. Number 2, the green one. Where do we start? At 1 again, and from there we go. Careful. Up to over 1. Looks like that. Then we've got the purple one here. Where are we going to start there? At 3 right there. And from there we're going to go down 1, over 4. So we get that line. And finally in the red, where do we start? We start at -2 right there, and from there we go. We wait for the computer to come back up. Okay, hopefully is it back up on both sides? Okay, so from there, what do we do? Up 2, over 3. Any questions there? That's it. You know what you did on the other ones? Just mix up rise and run. That's the most common mistake. And it is, I will say this before we do any more examples. It is confusing as heck when we graph. Because if I ask you to plot the point 3, 5, what direction are you going to go first? Yeah, we're going to go right to the 3, and then we're going to go up to the 5. Yes, when we are graphing, yes, we start out with the up and down. -1 goes down 1. And then with the slope, we do the same thing. We start out with the rise. That goes up 2 and then over 1, 2, 3, 4, 5. And yes, that does, it tends to confuse the heck out of people. But there's a difference between plotting points and then this is what they call slope-intercept graphing here. So just a little bit of a warning on you. Be careful. As we look at this one, what looks different than what we've seen so far? Yeah. All the ones we've looked at before have been y equals. This one is y plus 2 equals. We can't have that. We have to get rid of the plus 2 over here. We have to solve this and we have to isolate the y. We're solving for y. So how do we get rid of the 2 here? We're going to subtract it. It's been added to the y, so to get rid of it, we subtract it. Well, when we add or subtract in an equation, we have to do it to one piece on each side of an equation. So I subtracted 2 over here, made that 2 go away, leaves me with y. On the other side, I have to subtract 2 from one piece. Can I subtract 2 from the 1/3 x? No. I can subtract 2 from the positive 1. I can only add or subtract, remember, from things that have the same name, same label. So 1 minus 2 is -1. Perfect. So now that's what I graph. Where do I start with it? -1 is my first point. From there I go up 1 and then over 3. Like that. What's different about this one down here on bottom? It's 3 times y. How are we going to get rid of that? We have to divide by 3. When we multiply or divide an equation, we have to do it to every digit. Remember, the algebraic word for digit is term. Every term or every digit in that equation has to be divided. So the 3y is one digit. That gets divided by 3, and it leaves us with y. Well, on the other side, we have to divide that whole side by 3 as well. Again, each digit. 2x is one digit. What's 2x divided by 3? Well, I'm going to show you a little trick here. Since the 2 and the 3 don't divide out evenly, just make it a fraction. It's 2/3. 2/3 x. But we must also divide the 6 by 3, which is 2. It's a positive 2, so plus 2. So where are we going to start graphing that one? Positive 2 from 0, yep, right there. From there, we're going to go now up 2 more. Yep. And over 3, right there. Looks like that. What do you think? Better than sharp sticking you yet? Barely. I had a student one semester ask me, will you stop when you get to the back of the skull? Looking at this one, there's a couple of things that are going on here. It's not only, y has not only been multiplied, it's also had something subtracted from it. This is just like solving our other equations, only we're focusing just on this side here. And what we're trying to get by itself now is the y. And what's keeping the y from being by itself, of course, is the 2 and the 1. 2 has been what operation? Multiplied, yep. And the 1 is subtracted. Order of operation says which happens first? Multiplying. So this equation was built, the y was multiplied by 2, and then the 1 was subtracted from it. But remember, when we take it apart, you take off the last piece first. You gotta go backwards. So what's the first piece we're gonna get rid of? Yeah, the -1, we're gonna get rid of it by adding 1, exactly. So we add 1, makes that go away. Remember, when we add or subtract, we have to do it to one digit on each side. So adding 1 gets rid of the -1, leaves us with 2y. On the other side, where do we add the 1? To the 1. Very good. So that stays 3x. 1 plus 1 is positive 2. So to graph this, we start at Oh, good call. Yep. What do we have to do? Divide by 2 makes that go away. Y equals, now we have to divide by 2 on the other side. Remember, when you multiply or divide, you have to do it to every digit. So what is 3x divided by 2? Perfect. And 2 divided by 2? Positive 1. Now can we graph it? Yes, we can. Where do we start? Positive 1 is our y-intercept. That's from the plus 1. Then up 3 over 2. Very good. So we got 2y equals 3x minus 4. We've got y minus 5 equals 1/2 x minus 3. And we have 3y plus 2 equals 2x minus 5. I want you in your notes to graph those three for me. Okay, so for the first one here, what do we have to do before we can graph that? Well, what do we have to do to simplify it? Divide by the 2. So that's gone, gives us y equals. Now when we divide, do we do it to one piece or the whole thing? Whole thing. So 3x divided by 2 is 3 over 2x. Negative 4 divided by 2 is negative 2. So where do we start to graph that one? Negative 2, and from there we go up 3 and over 2. Good. The second one, what do we have to do before we can graph that? Yeah, it's y minus 5, so we add 5. Makes that go away. Gives us y. When we add, do we do it to the whole thing or just one piece? Just the same. The negative 3. Very good. So the 1/2 x doesn't change. Negative 3 plus 5 is positive 2. So where do we start with that one? Up 2 right there. And from there we go up 1 over 2. And then we've got the last one down here. What do we do with that one before we graph? We start out by subtracting 2. That leaves us with 3y over there. Where do we subtract 2 on the other side? From the negative 5. So the 2x doesn't change. Negative 5 minus 2 is a negative 7. Then what? We divide by 3. So the 3 cancels out. Y equals. We have to divide that whole side by 3. So it's good. 2/3 x minus 7 over 3. So 7/3 is 2 and 1/3. That's about right here. Then from there, we've got to go up 2 and over 3. Not pretty because of the fractions, but it still works. Oh, I'm sorry. You are correct. Yep. No, you're not confused. I'm not paying attention. It should be at negative 2 and 1/3 right there. Then up to over 3. Nope. Negative 7/3 is negative 2 1/3. For the y-intercept, it is okay to have mixed numbers. For the slope, however, that has to stay improper because that's a ratio. Okay, it is about time for our break, so it's 10:14. Let's go ahead and take a break, come back at 10:25.